Hey there, for those that are fairly new to Seestar and astronomy image processing, I thought I'd put together this short video to give you an introduction on how to do mosaic processing from tiles that have been captured in a Seestar session. So with no further ado, let's go ahead and get started. First, you'll notice here there's 6 files, and this is a capture of the Rosette Nebula, sometimes referred to as NGC 2244. And these 6 files represent where Seestar has captured multiple 20-second images, and then Seestar has done the stacking. And so these each represent a tile of multiple stacked images, and I'm going to go ahead and use those. So the first thing we need to do is to stitch these files together, and I'm going to use a program called Astrometric Stacking Program, often called ASTAP or ASTAP. The first thing I need to do is to open up the stack and browse for those 6 files. So I'm going to do Control A on my Windows machine, click on Open, and you see those 6 files are then represented. Now in the Stack Method tab here, I'm going to make sure that Image Stitching Mode is selected, and then in the alignment I'm going to make sure that Astrometric Alignment is selected. And that's it for the ASTAP program. I'm then going to go and click on Stack, and it's going to take a few minutes to go ahead and add the files and then start to stack the images and stitch them together. Alright, so ASTAP has done its magic. It took about 3 minutes, and you'll see now that over here we've got 2 new files in Explorer, and ASTAP is telling us that it's finished the stitching. So we're going to go ahead and we'll close down ASTAP because we're done with it. And the next thing we want to do is we want to open up the stitched file, basically to take a look at it and maybe do some denoising. So to do that, I'm going to open up a program that's called GraXpert. And so let's go ahead and open that, and I'm going to load that image, that stitched image, into GraXpert. So you can see here, here's the stitched image, and we double click on it and it's going to load. And you'll notice basically what I see, at least, is over here there's a little bit more noise in this tile area than in the other areas. So I'm going to go ahead and use GraXpert to do a denoise. And so I go down here and I've set my denoise strength to 1.0, and I'm going to click on denoise the image. And then what GraXpert does is it's using artificial intelligence, and basically it's looking at information that it has about various images of the Rosette Nebula and what it should look like, and it kind of leverages that to do the denoise processing. Alright, so GraXpert has done its denoise processing. It took about 60 seconds, and you'll notice if I go up here I can compare the original, and you see some of the noise reappears, with the denoised version. So it's done a fairly nice job of reducing some of the noise. Next, I'm going to go ahead and click on saving. I'm going to save this processed image, and I'm going to save it as what's called a FITS format, and click on save. And you see that GraXpert version then appears in Explorer. So now we're done with GraXpert. The next thing we want to do is we want to use a program that's called Siril, and it's a fairly powerful image processing software. And by the way, I'll put all the links to all this software, which is all free, in the description in this YouTube video. So the first thing we want to do in Siril is we want to open up that GraXpert file, and you see it's right here. So I'm going to double click, and you see here, interesting, it's a completely black screen. That's because we haven't done any image processing yet. What you can do in Siril, if you go down here where it says linear, you can click on this and do what's called an auto stretch. Now, auto stretch doesn't actually materially change the image. It's just trying to give you a view of the image in an artificial stretch. And again, it's not touch the image file itself. But again, by doing that, we really don't see anything yet. That said, what I'm going to do in Siril is there's a thing called color calibration. So I go to image processing, color calibration, click, and I'm going to select photometric color calibration. I'm going to type in the name of this object and click on find. And the reason I do this is now I can use Siril and it will do its magic to represent the correct color for the Rosette Nebula in this particular image. So what Siril does is it searches through a database and sort of does an adjustment based on what the image should look like color wise. So I click on OK, and you can see here Siril is now looking at the image and it's checking different databases, and it tells me the photometric color calibration has succeeded. And so I can click on close, and now look at that. Now the Rosette Nebula has appeared for us. One of the things you'll notice is on the tiling in the Mosaic, the tiling didn't quite overlap the whole way. So we're going to crop out some of these black areas. I'm going to hold down my left button on my mouse in Windows. And I'm going to drag and take it all the way down to about here. And I'm going to right click and click on crop. So now we've cropped out those black areas. Now you notice I'm still in auto stretch. So this is kind of an artificial representation of the image. We haven't actually done any image processing per se yet. But the next thing I like to do is I like to do what's called remove green noise. So sometimes in your image you may have some green noise that creeps in from either light pollution or other aspects, but you can do this by click on green noise and just click on apply and then click on close, and it's done a minor change I can see on the image. So the next thing we want to do is we now want to go into what's called stretching. Stretching is basically where you increase the brightness and the contrast selectively in different areas of the image. And I'll run through that right now. So first thing, we go into linear. And then we go into the top and we're going to do what's called a generalized hyperbolic stretch transformation, GHS. And when I open up that dialog, you've got a number of things here that we want to pay attention to. The first thing is the local stretch intensity. I'm going to drag that all the way to the right. And then the first thing I'm going to do is I'm going to do an initial stretch using the stretch factor on this image. And when I drag this, you'll see that the image starts to lighten up a little bit. Now, I don't want to go too far. And the reason being, if I go too far, I start to emphasize some of the noise in the image. Even though we've done a noise reduction, that noise can still re-emerge. So I'm going to click on apply. And then I'm going to go up to the top here and go to linear stretch. BP shift is black point shift. So now I'm going to actually drag this black point slider here very slightly to the right, just before it hits the blue curve here. So just before it hits there. And the reason I've done that is I've now darkened the background. So any chance of any noise emerging, I've kind of reduced. And I click on apply. Then I'm going to go back to the first thing that we did, but I'm going to leave the local stretch intensity just a little bit lower. And then I'm going to do stretch factor again. And now you can see the images start to lighten. Don't go too far. Click on apply, back to linear stretch, and then drag just before we hit that blue curve there, or the blue peak. Click on apply. And then we go back to the hyperbolic transformation and we stretch again. I'm going to do this iteration probably 7 or 8 times. And so you'll see me do this quite a few times. But you can see here the Rosette Nebula is now starting to appear. So I've been running through this stretch between the generalized hyperbolic transform and the black point quite a few times. And so now we're at the point now where I've done another generalized hyperbolic transform. Click on apply. And now I'm going to go to the black point stretch here. And again, I don't want to go too far. I don't want to darken it too far. Click on apply. And let's go back to the transformation. And we'll maybe stretch one more time. You can see now if I stretch too much, look at the bottom here, this noise is starting to appear. We don't want to overstretch. So let's just back it off a little bit. Maybe down to about here. Click on apply. And again, repeat the process. Linear stretch, black point, drag over. And so now we darken the sky a little bit more. Click on apply. Now I'm going to go back to generalized hyperbolic transform. And there's a little trick that I want to show you where you can emphasize some of the nebula areas without also increasing the background brightness. So what I'm going to do is I'm going to hold down my left mouse button and drag this small area of the nebula that doesn't have any stars in there. Then I'm going to go over to symmetry point, and there's a little eyedropper here. I'm going to click on that. And now I'm going to do the stretch factor. And you'll notice what happens is the brightness of the nebula is increasing, but the background isn't increasing as much. So we'll stop about there. You can see we've got some nice nebula appearing in the outer areas. But I want to be careful because there is some noise starting to appear here as well. So I'll click on apply. Then I go to the black point. And let's drag that in just a little bit more there. And I'll click on apply. And then I'm going to close this. And then just click once here for that little square to disappear. So I think you agree with Siril, doing this stretching is a nice capability where you can bring out some of the nebula without sort of bringing out too much noise at the same time. What I can now do is I can now save this file, and I can save it in a number of ways. One is I can save it as a FITS file, and I'm just going to add on the word Siril on the end of the file name here. I'm going to click on save. I'm going to save it as a 32-bit, and the reason being is just if I want to do future processing in Siril, 32-bit offers me a bit more capabilities. Now, if you want to go and do post-processing in, say, Photoshop, you'll need to save it as a 16-bit TIFF file. So let's go ahead and do that. So supported image files, let's do TIFF, or you can do PNG. Click on save, and now make sure you save it as a 16-bit file ready for Photoshop. Click on save, and you can see here in my Explorer window those files have now been saved there as TIFF and FITS. So that's it. It's a pretty basic introduction of doing mosaic stitching and then some fairly simple image processing in Siril. And so I encourage you to take a look at all these programs and then maybe play around even more further in your Photoshop. Thank you.